This article is being read by an automated voice. Chapter 1.4 HFOs and the Growing Threat of TFA. Because of their harmful impact on the ozone layer, CFC and HCFC refrigerants have been phased out globally under the Montreal Protocol, while HFCs are being phased down under the Kigali Amendment to the Montreal Protocol because they are high GWP greenhouse gases. This leaves the fourth generation of F gases, HFOs, which don't have the negative environmental impact of their predecessors because of their zero ozone depletion potential and extremely low GWP. HFOs and their blends are now the biggest competition facing natural refrigerants. However, HFOs have their own issues, namely that some of them, notably the most prevalent one, HFO 1234YF, readily form trifluoroacetic acid upon leaking into the atmosphere. TFA is absorbed in rainfall and infiltrates the environment. TFA, like many F gases, falls under the chemical class called PFAS, or forever chemicals that don't break down in the environment, according to the scientific community. TFA has been found in increasing amounts everywhere in the environment, in rain, surface water, soil, human blood serum, plants, plant-based foods and drinking water, and there are signs it could be harmful to human health. HFOs may be the biggest source of TFA, but others include the breakdown products of certain insecticides, pharmaceuticals, fluoropolymers, and other PFAS, as well as the direct release of industrially produced TFA and TFA emitted from wastewater treatment plants and landfills. TFA is extremely hard to remove from water, though recently a possible improvement to the process has been proposed. HFO 1234YF, a slightly flammable A2L gas, has become the standard refrigerant in millions of car air conditioning systems throughout the world, replacing HFC 134A. When HFC 134A leaks into the atmosphere, it takes more than a decade for 10 to 20% to transform into TFA. But when HFO 1234YF escapes into the atmosphere, it takes no more than a few weeks for all of it to convert to TFA. Moreover, HFO 1234YF is commonly found in blends with HFCs such as R448A and R513A that are used globally in commercial and industrial refrigeration. These systems leak significant amounts of refrigerant due to their complex piping systems. Regulations in Europe and the US now call for, or are heading toward, requiring refrigerants with a GWP less than 150 in new equipment. This has led to the development of new HFO-HFC blends such as R454C, R455A, and R471A, which have a GWP of 148. The use of HFOs will not slow down until regulatory bodies in the EU and possibly in certain US states take action to restrict them. Globally, the chemical industry has opposed regulations on HFOs, saying they do not represent a threat to human health. However, Robert Bilott, an award-winning and widely profiled U.S. environmental attorney, whose lawsuits over a two-decade period first exposed the environmental and health threat of PFAS, sees history repeating itself in the way the chemical industry is characterizing refrigerants. Among the many stakeholders voicing concern about TFA, Christine Lutskendorf, policy advisor on fluorinated greenhouse gases for Deutsche Umwelthilfe, recently called for an immediate stop to TFA emissions given its infiltration throughout the global environment and its real risk to human health. Another observer, Michael Kaufeld, professor at the Karlsruhe University of Applied Sciences, Institute of Refrigeration, Air Conditioning, and Environmental Engineering in Germany, predicts that because of TFA's environmental impact, in 8 years HFOs will no longer be a viable refrigerant, leaving natural refrigerants as the primary option. Spate of studies. Regulatory action may be supported by the spate of studies tracking the proliferation and potential harm of TFA in the environment. One of the more striking recent studies makes the case that TFA meets the criteria of a planetary boundary threat because of increasing planetary scale exposure, where potential irreversible disruptive impacts on vital Earth system processes could occur. The paper reviewed 43 studies from the late 1990s to the 2020s that reported on TFA concentrations, concluding that collectively, these data indicate that TFA exposure is widespread and is increasing. Exposure to TFA and ultra-short-chain PFAS with 2 carbon atoms has not been conclusively associated with health effects, but the German government in 2024 proposed to the EU linking TFA to reproductive toxicity in labeling based on evidence of embryo-fetal developmental toxicity in rabbits. TFA has also been connected to liver dysfunction in rats. The planetary boundary threat study states that there are more than sufficient data to conclude that TFA poses a risk to humans and the environment, and that transitioning away from TFA and its precursors is the most effective way of safeguarding future generations from this planetary boundary threat. Meanwhile, other reports of TFA in the environment abound. The government of Wallonia, the French-speaking southern region of Belgium, disclosed in October 2024 preliminary results on the presence of TFA in drinking water, finding it in 598 out of 642 distribution zones, including 13 in which the 2.2 micrograms per liter guidance value was exceeded. Also in October, researchers reported increasing concentrations of TFA in Denmark's groundwater over the last 60 years. In September, Swedish researchers said they found elevated levels of TFA in juices and drinks, especially orange juice and some hand-squeezed oranges, as well as in fruit purees for small children. And in the U.S., a study of PFAS in rainwater in the state of Michigan found TFA to be the largest contributor in 2 out of 3 sample locations, and one of the largest in the 3rd location. The chemical industry addressed the environmental deposition of TFA in an October 2021 study funded by the Global Forum for Advanced Climate Technologies, which represents F-gas producers Chemours, Honeywell, Arkema, and Cura. The study concluded that with the current knowledge of the effects of TFA on humans and ecosystems, the projected emissions through 2040 would not be detrimental. But the study also acknowledged that the major uncertainty in the knowledge of the TFA concentrations and their spatial distributions is due to uncertainties in the future projected emissions.